Assalamu alaikum warahmatullah. Hi everyone. In this video I will be doing question 2 from the coverage of a grade 12 elite for term 2. So this suggested question from the college board says, consider the polar curve r equals 2 sine of 3 theta from 0 to pi. In the xy plane provided below, sketch the curve. Part B, find the area of the region inside the curve. Part C, find the slope. So what do we do in the first part? Okay, we have our graphing calculator in the exam. So we can sketch the polar curve on our graphing calculator and then copy what we get on the exam paper. So the scoring guide for this part has 2 points, and 1 point is given for sketching three petals, 3 leaves, and 1 point is identifying that the length or the maximum height of each petal is 2. So when you look at this polar curve, this number here is, as we studied in grade 11, this number here is odd. If this number is odd, that means that there are 3 petals, which is equal to 3. If it's even, we have twice that number of petals. And the maximum is going to be 2. This is something we did in grade 11. But you have your graphing calculator. Just type this polar curve in your graphing calculator, sketch it there, and copy it on the exam paper. So when you sketch this one on the exam paper, make sure that you reach to -2. That means the length of the petal is 2. And this one, it has to be 2. This one, it has to be 2 as well. So to get the full credit, make sure your sketch or your drawing is as accurate as you can. So the second part says, find the area of the region inside the curve. Inside the curve means inside the 3 petals, inside the 3 leaves. So how do we find the area? We'll use the integral, okay? But we can find the area of 1 petal and multiply it by 3. Or we can just do it for the whole graph at once from 0 to pi. You might be wondering why it's from 0 to pi. Because reason number 1, it's given from 0 to pi. Another reason is that we are tracing the curve from 0, and then this is how the curve is traced. And then all the way, so we stop at pi. So from 0 to pi, yes, we can trace this curve. But if you feel this is confusing, let's find the area of 1 petal and then multiply by 3. So here this is theta equals 0. And for the end of this petal, we've got theta equals pi over 3, which is 60 degrees, pi over 3. So the integral now is given by, this is part B. The area is given by the 1 over 2, which is something students always forget, 1 over 2, okay? 1 over 2 times the integral from A to B, r of theta squared d theta. So we have the area equals 1 over 2 times the integral from 0 to pi over 3 times 2 sine of d theta all squared d theta. So this integral will give us the area of 1 petal. So we will multiply by 3. So let's multiply now by 3. So we've got 3 times 1 over 2 times what? Look at the 2 sine of 3 theta all squared. 2 squared is 4. It's a constant, it's a coefficient. We can write it in the front. So 4, because this is 2 squared, okay? We can write it as 4. And then times the integral from 0 to pi over 3 sine squared of 3 theta d theta, okay? So, sine squared of 3 theta or sine squared of x sine squared of theta, this is an identity. So we have an identity that says sine squared of theta equals 1 over 2 bracket 1 minus cos of 2 theta. This is, okay, this is the previous, no, here. So, this is an identity, okay? This is an identity, and notice that this is theta, and this is double the angle. Yani, theta 2 theta, 3 theta 6 theta, 4 theta 8 theta. So, let's go back and use it here. Let's use it here. So what do we get? We have the area equals, now if 3 times half times 4, this is equal to 6, right? Times the integral from 0 to pi over 3 times 1 over 2 bracket 1 minus cos of 3 theta becomes 6 theta d theta. And here we have the area equals 1 over 2 times 6, it's 3, times the integral from 0 to pi over 3, 1 minus cos of 6 theta d theta. And this is equivalent to what? 3. The integral of 1 is theta, minus the integral of cos is sine of 6 theta, divide by the derivative of the inner, which is 6. That means we are multiplying by 1 over 6. And this is evaluated from theta equals 0 to theta equals pi over 3. Now we can go for upper minus lower. We've got 3 here, and this is pi over 3 minus 1 over 6 times sine of 6 times pi over 3, okay, minus 0. If you plug in the 0, it will be 0. So, 1 minute, this is 6, and then this is pi over 3. Now sine of 6 times pi over 3, it means sine of 2 pi. Sine of 2 pi is 0. So this quantity here becomes 0. And 3 times pi over 3, it will be only pi. The final answer, or the area of the region inside the curve, is equal to pi. Why did I use it manually, not by the calculator? Because I'm following the instruction of the FRQ questions. For example, this in AP classroom, this question is a non-calculator active questions. And some students will be doing the actual AP exam within 2 months from now. And there is one section for non-calculator free response questions. So this is how it's done. But again, for the purposes of the final exam, you can check the scoring guide, how the results are distributed. Okay, so the third part, find the slope of the curve at the point where theta equals pi over 4. So we need to find the area, the slope of the curve at the point where theta equals pi over 4. So, to find the slope equals dy over dx. So we need x and we need y. And we know that x equals r cos of theta and y equals r sine of theta, and r is given. So r is given, right? So r is 2 sine of 3 theta. This is multiplied by cos of theta. And again, this is 2 sine of 3 theta. And this is multiplied by sine of theta. Now, after finding x and y, we need to find dx over d theta and dy over d theta. So we will use what here? The product rule. So we'll call this one first, and we will call this one what? Second. Why did we name them? To use the product rule. Because the next step is finding what? dx over d theta. We need to find also dy over d theta. Okay? So dx over d theta, we will apply the the product rule. Differentiate the first, leave the second, plus leave the first, differentiate the second. So differentiate the first, the derivative is going to be, we have 2 in the front. The derivative of sine of 3 theta is cos of 3 theta times 3. So 3 times 2 is going to be 6 cos of, okay, so this is wrong. This is eraser. 6 sine of 3 theta. Okay, we differentiated the first, leave the second, plus leave the first, differentiate the second. The derivative of cosine is minus sine. So sine here, and I'm going to change this one back into minus. Okay. And let's do the same for the second one. So that is going to be 6 cos of 3 theta. Leave the second sine of 3 theta. The second is sine of theta, not sine of 3 theta. Plus leave the first, which is 2 sine of 3 theta, differentiate the second, which is cos of theta. So these are the 2 derivatives, dx over d theta and dy over d theta. Let me just double check what we have done. Differentiate the first, leave the second, plus leave the first, differentiate the second, and the second one, the derivative here is 6 cos of 3 theta, leave the second, plus leave the first, differentiate the second. Now I want you to plug in pi over 4. Substitute theta equals pi over 4 in both, here and here. Substitute theta equals pi over 4 in both, and what do we get for the first one? We get for the first one dx over d theta. We are supposed to get minus 4, and for dy over d theta, after substituting the pi over 4, you should get minus 2, but we are looking for dy over dx. We are looking for what? For dy over dx. And we know that dy over dx equals dy over d theta all over dx over d theta, which is going to be negative 2 over negative 4, which is half. So the slope equals half. I hope this was clear, and that's it. رمضان كريم.